Welcome back to Chapter 5, Water Completes the Mix of the Kids' Book of Weather Forecasting. This chapter will start on page 64. Water completes the mix. Warm weather, cold weather, hot, sunny beach days, and crisp kite-flying days. What's missing in our weather mix? Water. We have precipitation in the forms of rain, snow, sleet, and hail because water is in the air. Once you understand the effect of air temperature on that water, your forecasts will go a long way toward helping people understand how the weather affects their comfort level, whether they're bundling up against the sleet and snow or trying to keep cool on a sticky summer day. Disappearing puddle act. After it rains, find a puddle on your driveway or the sidewalk, or grab the hose and make one. Trace around it with chalk. Record the time of day and what the weather is like in your weather log. Come back several times and trace around it, each time in a different color. What happens by the end of the day, if it doesn't start raining again? No more puddle. The water in your puddle evaporated. This means it changed from liquid, water, to a gas called water vapor. The warmer and drier the air, the faster the water disappears. Remember what happens to warm, light air? See page 23. As the water vapor joins the warm, light air, it floats upward to mix with the other gases in the atmosphere. Weather words. Any kind of water falling from the sky, rain, snow, drizzle, hail, is called precipitation. Making a hair hygrometer. Measure the humidity using a strand of your hair. Here's what you need. A waterproof glue, 5 popsicle sticks, a strand of your hair, soapy cloth, and waterproof markers. Here's what you do. Glue 4 of the sticks to each other in a row. Then glue the 5th stick at the top so it forms a T. Gently wipe off the strand of hair with the cloth. Glue one end of the hair to the horizontal stick. Mark the length of your hair on the vertical sticks. Head outside with your hygrometer and stick it into the ground in a spot where it won't get knocked over. Put rocks around the base if you need to. To measure the amount of water vapor in the air is called humidity. Meteorologists use a hygrometer. Be a meteorologist. How humid is it? Every day, examine the hair on your hygrometer. Holding a sheet of paper behind the hair makes it easier to see. How does the strand look when the weather is warm and dry? How does it change when it rains? Does the air feel different to you when the strand changes? What relationship do you observe between strand length and the general weather? See how important the relationship between general observations and scientific observations is in forecasting? It's just a guess, but I think it's very humid in here. Hair soaks up the water vapor in the air, so a humid day, more vapor, sure can change your hairstyle. Some people end up with a slicked down, straight look as their strands of hair respond to all that moisture by getting longer, while people's hairs expands so that they turn into curly heads or frizz tops. Ask Mark. My hygrometer only showed me whether the air was dry or humid. Can I measure how much water is actually in the air? Sure you can, but to measure the humidity, you'll need another kind of hygrometer called a psychrometer. Meteorologists compare the amount of moisture in the air to the total amount of moisture that the air could possibly hold at that same temperature. They express this comparison as a percentage called the relative humidity. Remember, percent means in every 100. I'm sorry, but there's a limit of 100 parts of water per Volkswagen. That's okay, there's only 50 of us in here, which means the relative humidity in here is 50%. Can I honk the horn? Remember, percent means in every 100. So when the air has a relative humidity of 50%, it is holding 50 out of a possible 100 parts of water vapor at that temperature. If the relative humidity is 100%, the air is holding 100 parts of water out of a possible 100 parts, so it can't absorb any more. Warm air can hold more moisture than cool air, so when the air temperature changes, the relative humidity changes. Do you know where that water came from? You've probably already felt the effects of a change in the relative humidity. What happens to your sneakers when you walk across the grass early on a summer morning? They get soaked. During the night, the air temperature just above the ground cools down. If the temperature gets so cool that the relative humidity is at or close to 100%, then the water vapor or gas begins to condense, turn back to liquid. These little droplets of water collect as dew on exposed surfaces like the grass. The temperature at which the water starts condensing is called the dew point. If the air temperature near the ground is below freezing, 32 degrees Fahrenheit, when the dew point is reached, the water vapor turns to ice instead of water droplets. We call that moisture frost. Marge, it's getting cooler and I've been thinking about condensing. Oh, Harry, what will the neighbors say? Weather lore. Dew on the grass, rain will never pass. This saying is a keeper. Dew can only form if there's no wind and few clouds. A heavy cloud cover would keep the heat from rising into the atmosphere, so the air couldn't cool to its dew point temperature. Wind would blow air over the ground, also preventing dew from forming. The calm, clear skies that allow dew to form also means good weather, so morning dew does signal that conditions are right for a pleasant day. Make a psychrometer. Use this psychrometer to determine the relative humidity of the air. Here's what you need. Scissors, empty cardboard milk or juice carton, 64 ounces or 2 liters, glue, 2 thermometers, and shoelace or gauze. Here's what you do. 1. Cut out a rectangle from the front of the carton at the bottom. Glue the thermometers to the carton so the bulbs are in front of the hole. Soak the shoelace in water, then wrap it around the bulb of 1 thermometer. The dry bulb thermometer records the air temperature. Thermometer wrapped in the wet gauze is your wet bulb thermometer. As the water in the shoelace evaporates, the temperature of this thermometer will drop. Using your psychrometer. Set up the psychrometer on a table and let a small fan blow on it until the temperatures stop falling. Record the temperature of each thermometer in your weather log. Then subtract the temperature of the wet bulb thermometer from that of the dry bulb one. Using charts on page 134 or 135, find the air temperature, the dry bulb temperature, in the column on the left as the difference between the two temperatures in the row along the top. The number where the row and column intersect is the relative humidity. Try it. Let's say the room you're in is 58 degrees Fahrenheit, the temperature of the dry bulb thermometer, and the wet bulb temperature is 50 degrees Fahrenheit. Find 58% in the column on the left of the Fahrenheit chart and 8 degrees Fahrenheit in the row across the top. The relative humidity in the room is 56%. The air is holding a little more than half the water that it can hold at 58 degrees Fahrenheit. So let me go to the chart. 134. Hold just a minute while I give you a picture of that chart. There it is. Relative humidity in Celsius and relative humidity in Fahrenheit. Now, let's say the air in the room warms up to 68 degrees Fahrenheit while the amount of water vapor stays the same. You check your wet bulb temperature and it has risen to 53 degrees Fahrenheit. So the difference between the dry and the wet bulbs has increased to 15% Fahrenheit. What happens to the relative humidity? Answer. The relative humidity drops to 34%, the intersection of 68 degrees Fahrenheit on the left and 15 degrees Fahrenheit at the top of the chart on page 130. On the Celsius chart, 20 degrees on the left and 8 degrees at the top page gives a relative humidity of 39%. The conversion and rounding off of the temperatures results in this slight difference between Fahrenheit and Celsius percentage. Forecasters getting it right rules. As the air temperature rises, the amount of moisture in the air gets further away from the maximum amount the air can hold, and the relative humidity, percent of water vapor in the air, goes down. As the air temperature falls, the amount of moisture in the air gets closer to the maximum amount the air could hold, and the relative humidity goes up. Warmer, cooler. All right, we're going to continue On part 2, this ends on page 72.